Welcome back to Boomer's Playground, and today we're going to be doing section 2.8, which is basic operators and maths. So we know many operators from school, just like plus, multiplication, subtraction, division. In this chapter, we'll start with simple operators, and then we'll go into some of the stuff that isn't necessarily covered by like your basic math in school. So there are three terms that we need to use or need to know: unary, binary, and operand. An operand is what operators are applied to. For instance, in 5 times 2, there are two operands. The left one is 5, the right one is 2. Sometimes people call these arguments instead of operands. Really doesn't matter. The true term is operand, but most people will understand either way. An operator is unary if it has a single operand. So here, all we're doing is just switching whatever that number is to the negative version of it. Since there's only one operand here, this is considered a unary operation. And then a binary has two operands, so y minus x or y plus x or 5 times 2. So that's binary because there's two operands with some math in between it. So we have our normal stuff: addition, subtraction, multiplication, division, x just as you would expect. The two that are interesting are remainder and exponentiation. Exponential. That's what that is. The remainder gives you just what it says. It's also called I've seen it called modulo. And so what this does is this just gives you whatever the remainder of a division is. So 5 divided by 2 is going to be 2 with a remainder of 1. 8 divided by 3 is going to be 2 with a remainder of 2. 8 divided by 4 is going to be 2 with 0 remainder. And what you guys are probably listening to this and thinking, why the hell would I care about that? And what you normally use this modulo or remainder for is if you want to find out if a number is even or odd. Because if you use so let's say we have a equals 2, and we'll do b equals 3. So what we can do is we do a modulo 2 equals 0. So what this is doing is this is saying, okay, divide a by 2, and we know that an even number, 2 is going to go into an even number equally, and we're going to get a remainder of 0. And then here, like if we do b, we're going to get false because, because 2 goes into 3 one time with 1 remainder. So this is going to be the main use case for this modulo. I'm sure when you get into some more like data science-y stuff, there might be other uses for it, but for just regular front-end stuff, it's mainly just going to be used to check if a number is even or not. The exponent is just that. It's 2 to the whatever power. So here it's 2 to the second power. So you'll see right here 2 with a little 2 in the top right. This is 2 to the third power, and then this is 2 to the fourth power. The exponent is just take this number and times it by itself this many times. So 2 times 2 is 4, 2 times 2 times 2 is 8, and 2 times 2 times 2 times 2 is 16. So all it's saying is take this number, multiply it by itself this many times. Just like in math, so this is just showing how you can check the square root or the cubic root. I wouldn't worry about that. Again, this is going to be one of those things that if you need to use it, you'll know and you'll have a resource to like get better with it. So I'm not really going to do much about that stuff there. String concatenation with the binary plus sign. So let's meet some of the JavaScript features that are different than what you were taught in just regular math class. So if you take two strings and you put a plus sign between them, it concatenates them or puts them together. Now, one thing I want to show is you'll notice that there's no space between my and string, and that's because there's no space in either string. So if we do this, now we have that space because we put one right here, or we could do it over there, or we could get super ridiculous and do it like that. So it's literally going to take the string exactly as it is. It's not going to cut any of the white space out, and it's just going to smash them together. Now, when you're using a plus sign, if there's a string on either side, it's going to convert both of them to a string, and it's just going to smash them together. So you'll see here we have 1, the string of 1 plus the number 2. So this is a string, so it turns this to a string, and we just smush them together. So we get 12. Same here, we've got 2, which is a number, plus, and then we have a string, which is 1. So we come over here, JavaScript converts 2 to a string and smushes them together, giving us 21. It doesn't matter whether the first or the second operand is the string. Here are some more complex examples. So here we get 41, and that's because math goes left to right. Also there's priority in the operands, which I think is a little further down. So 2 plus 2, so we have a number plus another number. So this is going to do the math as numbers. So we have 4, and then 4 plus the string of 1 is going to convert 4 to a string, and it's going to smush it together, and we're going to get 41. So we have the 2 plus 2 plus 1. So the first thing that happens is this 2 plus 2 happens. We get 4. And now we're going to do this part, but since that's a string, JavaScript automatically converts this to a string, and now we get 41. And so here, kind of the opposite, because this is a string, it's going to convert this to a string, smush them together, which is going to make it 12. So we have 1 plus 2 plus 2. So we have a string plus a number. Since one of them is a string, it's going to convert the second one to a string. And so now we get 12 plus 2, which is then going to be also converted to a string because we have a string on this other side. And we get 122. And that's all it's saying here is the first string, converts it. So pretty much what I just showed. The binary plus is the only operator that supports strings in such a way. Other arithmetic operators work only with numbers and always convert their operands to numbers. And so remember, the operands are just the numbers. So 5 and 2 or whatever the numbers are. All right. So like here, we'll see this. Since it's a subtraction, it's going to convert 2 to a number, and it's actually going to do the math. Same with the divider here. It's going to automatically try and convert everything to a number. It successfully does for these two, and we get 3. And then we have numeric conversion with a unary plus operator. So if you put the plus sign in front of anything, it's going to convert it to a number, or it's going to try to convert it to a number. So since 1 is already a number, nothing really happens. It just stays a number. Y is negative. This is just showing positive or negative. It's just going to keep the number whatever it is. So again, this is a actual number, so it doesn't do anything with it. And then here we have plus true. Well, true is not a number, so it's going to convert true to whatever its numerical equivalent is, which is 0 or 1. And then we have plus empty string, which is going to convert that to whatever its numerical value is, which is 0. And same with, like, if this was false, this would be 0. This could be anything really, and it would be it would try and convert it to a number. If it couldn't, you would get not a number, the capital N, lowercase a, capital N. It actually does the same thing as the number stuff we saw in the last chapter. It's just shorter. So here we have apples and oranges. We have a string of 2. We have a string of 3. So if we add them together, it does what it does with strings, and it just smushes them together, concatenates them, and we get the string of 23. So here we're using the urinary plus operator. So we're converting this to a number. So it's turning it to the number 2. And we're adding it to, and again, we're turning this to the number of 3 instead of the string of 3, and we do get 5. And so we need to do this with the plus sign because remember, the plus sign concatenates strings. It doesn't automatically convert everything to a number like the other arithmetic operators. From a mathematician standpoint, the abundance of pluses may seem strange, but from a programmer standpoint, it's nothing special. This is just stuff you'll see as you're doing more stuff. Again, remember, none of this is, you're not supposed to memorize. So we have operator precedence. And so this is going to make it go in order. So just like if you remember, like in America, we have PEMDAS, where it's parentheses, exponent, multiplication, division, addition, subtraction, and they go in that order. So it goes left to right, and it finds the things with the most precedence, and it does those things first. Now, if you want to make sure something runs first, you can just wrap parens around it, and that will always run first. So let's take that for example. So 1 plus 2 times 2. So we're actually going to get 5 because multiplication has a higher precedence than addition. So the 2 times 2 is going to happen first, which is 4. And then we're going to add 1 plus 4, and we're going to get 5. But let's say we wanted to make sure that the plus got done first. If we wrap it in parens, we get 3. So it's actually going to do that one first. So we're going to get 3, and then it's going to times it by 2, and we're going to get 6. So you'll see parens used a lot. That's just, like I said, if you need to make sure that this runs before everything else, that will give you that option. As we can see, the urinary plus has a priority of 14, which is higher than the addition. That's why in the example above where we had the plus apples, plus oranges, it's just showing that those worked first, which converted them to numbers so that the plus sign would actually do the addition. The last note is the assignment. It's also an operator, and it's got the super lowest priority, so 2. So it's the last thing to ever call. And all this is doing is saying, hey, whatever's happening on the right here, put that into this variable on the left. So here we'll get 2 times 2 is 4, and then we'll get 4 plus 1 is 5. And again, this is multiplication, so this will run first. It just happens to be in the right order. The fact of the assignment being an operator, not a magical language construct, has an interesting implication. All operators in JavaScript return a value. That's obvious for plus, minus, but it's also true for the equal sign. And so that's kind of what I was saying is it's taking the thing on the right and it's returning it to whatever the variable or the thing on the left is. So in this instance, this is kind of interesting. So we have the parens, which means this stuff is going to run first, but the equal sign is going to run last in this paren. So we have 2. So 2 is going to go there. We're going to have 2 plus 1 is going to be 3, which is going to put it into the A variable. And then we're going to take 3 minus 3, which is going to be 0, and that's going to get put into the C variable. So sorry. Okay, where were we at? Sorry about that, guys. Okay, cool. So Yeah, let's see. We're going to do 3 minus. We got that. This is going to be A equals B plus 1. All right. So the way this works is B gets inserted into here. So we have B equals 2. So that's actually going to be 2. So we're going to do 3. And then 3 is going to get put into A. So A is now going to be 3. And since A is 3, 3 minus 3 is going to be 0. So that's going to make C 0. So let's go back here. All right, so you'll see A is now 3, B is still 2, and C is 0 as we expect. I'll be honest, I've never seen this in a code base, although I haven't seen every code in the world. I would not do this. I think this is just for example only. Yeah, no, you would not want to do this because this goes back to the thing I was talking about with code readability. Code readability is very important, and this just makes it harder to read. So in the example above, yeah, so we just kind of went over that. You can chain assignments. So like here we have ABC. I've already used those, so we're going to do D, E, F. And then we can go D equals E equals F equals 2 plus 2. So what's going to happen here is okay, so right out of the gate, D, E, and F don't equate to anything. So first things first is we're just going to do the simple math there. So 4 is going to be returned into F. So now F is 4. And then since F is 4, 4 is going to be returned into E. So E is 4. And then since E is 4, it's going to be returned into D. And so D is also going to be 4. Again, this is not something that you would really see or probably use in actual production code. I think this is just showing you kind of a deeper dive into JavaScript and the way that some of these things work. So chained assignments evaluate from right to left. So yeah, so just kind of like what I showed back here. Okay, so now modify in place. So we often need to apply an operator to a variable and store the new result in that same variable. So in this instance, we have n is equal to 2. So we're saying set n equal to n plus 5. So 2 gets put in here. So we get 7. So now n is 7. And then here we'll do 7 again because now n is 7, not its original 2. So now this will be 7, and then times 2 is going to be 14. So if we get let n equal 2, so n equals n plus 5, and you'll see we now have 7 because 2 got put there plus 5, and now n is 7. So when we do n equals n times 2, this is now 7 times 2, and you'll see now we have 14 for the variable n. So these can be done this way, but there's also a shorthand where you just do whatever the operator is followed by an equal sign, and that is saying the exact same thing as this up here. So this is doing the exact same thing. It's just shorter to write. Short modify and assign operators exist for all the arithmetic and bitwise operators. Such operators have the same precedence as a normal assignment, so they run after most other calculations. So what it's showing here is we have let n, I'm going to do m because I already have, or actually I can just do n equals 2. And so now we have n times equals, which again, that's just the same as n equals n times 3. So we're just doing n times equals 3 plus 5. And so what'll happen is we're running right to left. So we're going to do 3 plus 5 is going to be 8. And then we have this, and it's because we have this equals sign right there. That's why the multiplication doesn't come first, because we have our equals sign. Because if, so we're here now, and so it would be 2 times 8, and so n is now 16. So plus 5. So this is essentially what this is in the longhand, because we have the multiplication with this. That's why it didn't get run first, because we have the assignment operator. Yeah, so shows right there just what I just showed you guys. Okay, and then increment and decrement. If you just need to add by 1 or subtract from 1, all you got to do is plus plus or minus minus. Now, you can do, it's called, I think it says it somewhere right here. Yeah, prefix or postfix. So with the postfix, so the after, so we'll check something out here. So we'll do n equals 2. All right, so n plus plus. Now you'll see we got the number 2, which is weird because 2 was already what we were. We expect it to be incrementing by 1. But if we look at n, it is actually 3. So this is tough to see right here, but let's say we wanted to create a new variable, so like new num, and we did n plus plus. New num is going to be the number after it's been incremented, newer num, whereas if we do the prefix, we get the 5. Hold on. All right. Both of these, is there any difference? Yeah, so here's kind of what so we have counter of 1, a equals plus plus counter. So a is going to equal 2. So if you do the plus plus before, it's going to give you the new number. So the number plus 1 is going to be given to the variable. And if we do it after, it's going to give us the original number before it was incremented. So let's see. So we'll do counter equals 1, let a equals plus plus counter, and you'll see we get 2 because we did the post or the prefix. And so now we'll see counter equals 2. So let's do a equals counter plus plus. If I could spell right. And so here you'll see a, we still have 2, even though we would probably think that we should get 3, but it's because it's giving us the variable before it increments that extra number. Yeah, so here it's just showing, you know, even though you do post or pre, this number still gets incremented. It just changes what's returned. So here, yeah, so 0 plus plus counter, that's going to give us the number after it's been incremented. This is going to give us the number, or sorry, yeah, and this is going to give us the number before it's incremented. You're almost always going to use this plus plus on the other end. I don't think I've seen this in our code base at work at all. Yeah, and so here you can even do like within the operations. So we want this to actually be 2, so we do it beforehand, whereas if we do it afterhand, we get the number before it's been incremented, so it's still 1, so 2 times 1. Here, we're getting the number after it's incremented, so this is actually 2, so 2 times 2 is going to be 4. Yeah, so again, this is just saying it makes it less readable, and that's just really important. Readability is very, very important. Bitwise operators, I don't really know a whole lot about, and they even have a whole section, so this is one of those things. I feel like you might need a little more computer sciencey knowledge to truly understand these, but maybe we'll learn some stuff in the bitwise section. The comma operator is one of the rarest and most unusual operators. Sometimes it's used to write shorter code, so we need to know it in order to understand what's going on. It allows us to evaluate several expressions, dividing them with a comma. So, and then the result of the last one is returned. So 1 plus 2 is 3, but it gets thrown away. And then 3 plus 4 is 7, so that's what gets put into the variable of A. I cannot think of or see any situation why you would do something like this. I think they have another example. Yeah, so here, like we're creating A and we're setting it equal to 1. B is equal to 3. C is going to be equal to A times B. And then we're doing this. This is a for loop. Don't worry about this. We'll get into that in another, there's whatever section that's going to be on. Again, this is just not something you would do. This is awful, super unreadable. So, all right, postfix, prefix forms. What are the final values of A, B, and C? Okay, so A is 1, B is 1. All right, so C is going to be A after it's been incremented, so C should be 2. B will be given to us before it's incremented, so D should be 1. So let's see if that's right. Oh, crap, sorry. Z equals 1. It's because I created A already. So I should just, actually, I should be able to do, if I just do this. Nope, never mind. All right, Z and X. Okay, cool. All right, so A is actually going to end up being 3, or no, sorry, it's just going to be 2. So A will be 2, B will be 2, Z should be 2, and X should be 1. So A is 2, B is 2, Z is 2. Oh yeah, because it's the prefix, so we get it after it's been incremented. And B is 2. B is 2, X, sorry. And X is 1. All right, so that's just what we were expecting there. What are the values of A and X after the code below? So A is 2. All right, so we got let A equals 2, and X is going to be A, or 1 plus A times equals 2. Okay, so since this is in parens, this is going to be, so remember this little shorthand right here is really just saying A equals A times 2. So 2 times 2 is going to be 4. So A here is actually 4. And then 1 plus 4 is going to be 5. So a will be 4 and x will be 5. A is 4, x is 5. All right, so these ones are pretty fun. All right, so because we have a string first and it's the plus operator, this is automatically going to get converted to a string of 1. Gonna smush those together, so we just have the string of 1. And then since it's a string of 1 over here, so you'll see we got that. So now we have the string of 1 plus 0. It's going to convert this 0 to a string, again, because the 1 is already a string. And it's going to smush them together, and we're going to get 10. So here we have a string, but we have the minus. So this is gonna try and convert it to a number, and I don't know if you guys remember or not, but the number of an empty string is gonna be 0, and now it's empty string. Even if we had a space there, if we had anything else in there, it'd be not a number. Okay, cool. All right, so this is 0 minus 1. So yes, we'll do minus 1 plus 0. So because it's subtraction, it doesn't try and convert everything to a string. That only happens with the plus or the addition. So this ends up being 0. So then 0 minus 1 is going to be -1. And then this is a number, as is this. And so we just add -1 to plus 0, which will be -1. True plus false is going to be, so again, remember, because it's this, because it's the plus sign, this should do, it should end up being 1 plus 0, so it should just be 1. Okay, yep, so that was right, because true's numerical value is 1, false's numerical value is 0. 6 divided by the string of 3. Remember, the plus sign is the only one that converts everything to strings. Every other mathematical operator tries to convert everything to a number. So this is going to convert 3 to the number of 3, and we're just going to get 2, because 6 divided by 3 is 2. Same goes right here. It's the mathematical operator, so it's not the plus sign. So it is going to try and convert these two numbers, which this can be converted to the number 2, and this can be converted to the number 3. And you'll see we get 6. Here we get 4 plus 5. So 4 plus 5, and since they're both numbers, it's just going to do the math. So we are going to get 9, as you see right here. And then now we're doing addition, so it's actually 9 plus the string of px. And since one side is a string, and again, we're using the addition operator, it's going to convert the 9 to a string, and then it's just going to smush them together, and we get 9px. Here, same thing. Again, we're using addition, so it will try and convert these two strings. So this is already a string, so it will convert 4 to a string. It'll smush those together to be $4. And then because $4 is a string, and we're using the plus operator, the 5 will get converted to a string, and we get $45 as a string. So we got $$ plus 4. So you'll see it's converted 4 to a string, and it smushed them together. So we have that plus 9, and again, plus 5. And because this side is a string and it's the plus operator, we are going to convert 5 to a string and smush them together to get the string of $45. 4 minus 2, this is subtraction, so it does not convert to strings. It tries to convert to numbers, which 4 can be, so we will get 2. Like you'll see there. Here, for px, 4px minus 2. It tries to convert this to a number. This cannot be converted to a number, so this is not a number. So I'm pretty sure this whole thing is going to be not a number. Yeah, because you can't, so it ends up being this because p and x cannot be converted to a number. And if you're trying to do anything with not a number mathematically, you'll just get not a number back. All right, so here we got minus 9 plus 5. So again, it's the plus operator. So it's going to try and convert this to a string. So we're going to get this whole thing with 5 smashed in. All this white space is going to stay there, I think. Because it's not converting it to a number, it's just keeping it a string. And we'll do 5. Yep, and so you'll see we kept all that white space, and it just smushed the 5 in there because it converted it to a string. Because again, we're using the plus sign. So the same thing, but with a minus sign. Again, the plus sign is the only one that converts numbers to strings if there's a string in there. So this will convert to a number, which will get rid of all the white space. And so we'll have negative 9 minus 5. So we should have negative 14. Yep. And so it's going to convert this string to the number it is, 9. And then we're just going to continue on with the subtraction and get that. Null plus 1. This should be 1 because when you convert null to a number, remember its value is 0. Plus 1, so we still get 1 because like I said, so if we do number null, we get 0. And so it's just doing 0 plus 1. All right. And the last, or second to last one, we have undefined plus 1. Remember, undefined when converted to a number is not a number. So you'll see we have not a number right there. So we're doing not a number plus 1 is going to be not a number because you can't add a number to the not a number type. This, I think, will be negative 2 because it's going to convert it to a number, which is going to get rid of this tab and this new line, and it's going to get rid of all the white space. So it should essentially end up being an empty string, which when you convert that to a number is 0. So I think it's going to be 0 minus 2. So we should get negative 2. Yeah, we should get negative 2, but let's try it out. And we'll do minus 2. Yep, and that's exactly what we get. So we just went through all those. Oh, here's some, okay, cool. So this is kind of breaking it down as well if I didn't do a great job, but listen to how I explained it, then also go through this. It never hurts to have multiple resources when you're learning this stuff. So here's code that asks the user for 2 numbers and shows their sum. It's not working right now, and so what we're going to do is we'll copy this and we'll go over to my text editor here and we'll save it, and let's open this right there. Perfect. So we'll have a number 1 and then we'll have 4, and let me get my 4, and you'll see we get 14. Okay, it's kind of weird. And so I also did, let's try this again. All right, so we'll do 1, and then we'll do 2, and you'll see we get 12. And let me do, oh, that's right, I didn't want to do that. I wanted to console log it. Yeah, so if you do console log anywhere, what happens is it shows up in the console in your developer tools. So we have 1, and then we get 2, and you'll see we get 12. Okay, that's where it's not what we want. So let's do type of. We'll do type of. All right. So we'll do 1 and we'll do 2, and you'll see we get string and string. So I don't know if you guys remember, but when we were looking at the interactions, which this is going to be the same issue when you're grabbing elements from the DOM. So you're not going to use prompt for something like this, but it is the same problem. So prompt returns a string. So there's a couple different ways that we could resolve this. So if you guys remember, we can just do the plus sign right in front of them. That will convert them to numbers. And so you'll see we get 1, 2, and now we get 3. And again, that's because we use that unary operator that converts it to a number. Alternately, we could do, we can do this. And we should get the same results. And you'll see we do get 3 as well. There's another one. Number is relatively new, so you'll probably see parse int a lot. It does the exact same thing. And there's like just some additional stuff, like if you are trying to do like hexadecimal or something else. But if you just do parse int, it will automatically just convert it to a 10 base number. Or I think it's a 10 base number. Yeah, yep, the default is base 10. Yeah, so parse int is another one. I'm only sharing that because that is used. It's still used, and it was used a lot before number was a thing. So if we do that, you'll see we get 1 and 2, and we still get 3, perfect. And then alternately, what I would personally do is, I would just wrap the whole prompt in this. And this way, B is just automatically a number, and I don't have to worry about it. And so now we should get the same. 1 plus 2, you see we get 3. So this could also be parse int all the way around, but number is the newer one, so that's just the one we'll use. So that fixes that. And that is the end of the assignments, or the tasks. I hope you guys learned something today. If you have any questions, comments, concerns, please leave them in the comment section below. Other than that, like, share, and subscribe, and we'll see you in the next one.